Okay, so let's figure out what sine x, cos x, and tan x mean. So these are things called trigonometric functions, and it's how we're going to be. They're the functions we use in GCSE to conduct a lot of trigonometry. So let's see how they're defined. So they're defined on this graph. So sine x is represented by this graph. So let's begin with this. So we can see that x is the value that we put into sine x. And y is the output we get. So we can see that the output oscillates between 1 and -1. Goes up and down. And every 90 degrees it hits its peak, and then 90 degrees later it's back to 0, and in 90 degrees it's to -1, in 90 degrees it's to 0 again. So that's how it works. And this is the graph from -360 to 360. If they ask you to draw the graph, they'll usually say a range like 0 to 360. But they'll normally only ask you to do it from -360 to 360 or somewhere in between. What you need to realize is that the graph repeats its cycle every 360 degrees. So it repeats itself. It just does the same thing. So if you took this point here at 360, that would be the same as taking this point at 0. If you followed it along, you get the same values. Now for y equals cos x, it's the same deal as a sine x graph, but it's shifted. So this 90 degrees bit is the beginning of the graph. So it's like if you moved the sine x graph to the left by 90 degrees, you'd have it here. And instead, it just starts at a different point. So you can still see that it repeats itself every 360 degrees. It oscillates between 1 and -1. And every 90 degrees you go from 0 to a peak, either 1 or -1, and then 0 and then a peak. And it works like that. Now tan x is a little bit different. This graph moves like this, so it goes high, bigger and bigger and bigger, or smaller and smaller and smaller as you go every 90 degrees. So what these dashed lines represent are places where tan x basically goes to infinity. So these bits are not defined. So tan 90 or tan 270, tan -90, tan -270, none of them are defined. But if you get points close to any of these dashed lines, you'll get a number that's either very, very large or very, very small. Now, what we can see here is that now there's a phase of 180 degrees. So if you started 180 degrees later, you'd get the same graph. And it repeats every 180 degrees instead of 360 degrees like sine and cos. And also, it doesn't, sine and cos can only go from 1 to -1, whereas tan can go to any value on the y-axis. Okay, this is another this links in with our inverse functions. So each trigonometric function has an inverse function, and they're denoted with a -1. And that is basically if you took the value from y to be your x. So x and y have swapped around if you think about it. You don't need to know why that's the case, but that is the case. So now we look on the y-axis to get to the x. Imagine, in fact, what we can do is we can move this sign over We get x equals sine to minus 1 y. And that's how we get our inverse function. But you don't need to worry about that. But you just need to understand that when we're dealing with the inverse function, we go from 1 to minus 1, and then we can take any value that it hits. So sine minus 1 can be minus 90 degrees. It could also be 270 degrees. Both of them are correct. But you also need to realize that we can't have minus 2 or something to go in this, because it's not defined. We only have from 1 to minus 1. And similarly for cos. But for tan, we actually, again, we have all of these values defined. So we can have this, we can put any value we want as x into this inverse function, and it will still output a correct answer. Usually calculators output the smallest positive answer. So if you went with if you went for cos, if you went for cos minus 1 minus 1, like that, it would get the first positive value here, which would be 180 degrees. But minus 180 degrees is also an answer, because it intersects the graph like that. Okay, now let's go back to our right angled triangles. So, now let's consider an angle, theta, that we want to figure out, or that we want to deal with. Now, if we have a triangle that looks like this, again, we know a hypotenuse is the one opposite the right angle. But we can also label these two sides. So we have the adjacent here and the opposite here. Why are these called the opposite and adjacent? Well, we're looking at this particular angle. So if the angle is here, the side next to, or in other words adjacent to this angle, is this side here, and the one opposite to this angle is this side. So that's where we get these names. If the angle was here, for example, the opposite would be this side, and the adjacent would be this side. They'd be swapped around. Right. So now that we've labeled these, we can actually start working with them. So we can use sine, cos, and tan to work out sides of a triangle or angles of a triangle. And basically, this will work if you know. So use sine, cos, tan if you know one side and an angle which isn't the right angle, and you want to know another side. Or if you know two sides and you want to know an angle. Right. So, for example, let's look at case 1. So case 1 would be if we knew an angle, so this was 30 degrees, let's say, and we knew this side was 4. If we wanted to figure out this side, we meet this criteria, right? Because we know one side, 4, and we know an angle, 30, and we want to know another side, x. We could also figure out this side. It doesn't matter where, because we know that side and the angle. The second case is this. If we have an angle theta, we know two of the sides. Let's say we know 3 and 4. We know two sides of this triangle, and we want to know an angle. And that's how it works. So in these two scenarios, you can use these trigonometric functions we've learnt to figure out the extra values. Now, before I end this video, I want to let you know that this only works with right-angled triangles. If you have a triangle without a right angle in it, we have to start using other methods. But in the next video, we'll go over how we can tackle questions with these two cases.